So again, I'm the CEO and the founder of the company, which is called uRobots GmbH. We are located in Pforzheim in Germany, and I want to present today our product, which is called an iBot. And this is basically a pick and place solution, which requires only EDS NXT camera and a robot. Let me introduce our company. We are founded in 2015. We work for manufacturers, or we work with system integrators, which build production lines for manufacturers. And our main area is quality control and assembly control. And we develop computer vision software for this. So basically, we detect objects, count objects, we detect defects. So we do everything to make sure that our customer has the highest quality of his products. And since years, we are using artificial intelligence to solve these tasks, because on one side, artificial intelligence is robust. It works very well. It is very fast to implement a solution using artificial intelligence. On the other hand, sometimes this is the only way to go. Sometimes there are tasks which cannot be solved with a rule-based approach, or the time to implement a rule-based approach is just too big. Therefore, we work a lot with artificial intelligence. And one of our last achievements is artificial intelligence for object localization on two-dimensional images. This means we do not only detect a class of the object, but we don't only tell with our artificial intelligence what kind of object it is, but we also say where it is located, exactly the position and the orientation of that object. And artificial intelligence detects in one shot all objects of all trained classes on one image. And because it's an artificial intelligence, it also can learn a deviation in the look of an object. So for example, the objects might be flexible, or they can just differ one from another just a little bit. But artificial intelligence learns this and is able to predict the position with a very high precision. So as an example of how does it look like and how does it work with the flexible objects, I will show a short video. So this is actually me showing my hands to our artificial intelligence. And no matter how I put my fingers and no matter what the background is for my hands, they are still detected, and their position and orientation is detected quite precisely. The other example is this one. This is actually a ceiling which is made of rubber, I think, and there are handles on the corners. And our goal was just to detect these handles. And as you can see, no matter how I move it, the corners are detected. Their 3D position is drawn here. And if I drop over more items, they still be detected. So this is the same artificial intelligence trained on the other set of images. The next thing, so having that done, having that implemented, this artificial intelligence which localizes things on images, we thought, okay, the next step would be to implement the pick and place using that. Because if we know the position of an object in 2D, and we know where the camera is, so we know how to transform the 2D coordinates from the image to the robot coordinate system, and this can be used for pick and place operations. Of course, this has some limitations. So the objects shall be placed on a surface, and the height of the object shall be known. But there are quite a lot of tasks in this world which can be solved just by using a 2D camera and a robot. And at the beginning, we implemented this solution using a PC, so a computer, which has a GPU, a video card, and all the computation is done there. So artificial intelligence and transformation is done on the computer, and the computer then sends the data to the robot, and we use traditional camera just to collect frames. But then this winter, we received a new camera, and this is EDS NXT camera, which basically is a camera with a PC. More important, it has FPGA, so this means it is capable to run artificial intelligence right on the camera. It has an Ethernet communication, which is extremely important. This means we can communicate with everyone using this camera. And it is possible to create our own application. So there's an EDA, which is development environment, which is available. We can use it to compile software, to install it on the camera, to run it. And so we did it. So we poured our solution, which was PC-based initially, completely into the camera, and we run it there. And now this is how our final product looks like. This is just a camera which detects the objects, detects their position, transforms them into 3D coordinate system, and send this information to the robot. The robot uses this information where needed. So and our goal was to make this product available for large variety of customers, so they can use it themselves and they can train themselves in artificial intelligence. So we don't want really to collect images and do training in our facilities and then just deliver a project. We want to make a product which can be used standalone. And to solve that, there are two goals to be completed. First, it shall be user-friendly and it shall not require any expertise in artificial intelligence. And the second, the setup of the system and implementation of the solution with a system shall be done by a robot developer. So if you have a robot, you anyway have a robot developer to complete the setup, to commission the system, and the same developer with no extra skills shall be able to use our tool to implement pick-and-place operations. And this is how it looks like for our customers. There are 3 steps. First step is to prepare artificial intelligence. It's quite classical. It's supervised learning. Images shall be done. Images shall be labeled. AI shall be trained. The next step is to export the model, which is created on the PC. So the artificial intelligence still has to be trained on PC. It can be either computer of the customer, or he can use our computers via the internet, so actually in the cloud. And when the model is trained and exported to the camera, the robot developer shall program the robot using teaching. So later I will show what does it mean, the teaching in pick-and-place here. So I decided today to show an example, a very simple example, how we want to handle these clamps. So there's just a clamp, and I want to make a pick-and-place using the robot and the camera. First thing is the labeling. To do labeling, our tools has to be used. It's just a tool where on the left side you can see the list of files, the images which were done with the camera, and here in the middle there are this actually selected image and the set of labels which I created. So I decided to work with clamps and the screws. So I created 2 markers for both of them. And now as a customer, I bring my expertise and label the objects. So there are 3 clamps to label, and there are 2 screws to label. And as you can see, the labeling is quite easy, and the label looks, it's actually specialized. So I modified the way how label looks like to make the labeling process very convenient. In that case, for example, I created a circle which is drawn about the marker, so I can just put it on top of the hole of the screw. And using this, I can position my markers very easy. Now you can see I already labeled few images. I will just go through them. And this is what artificial intelligence will use as an input for training. So the next thing is training. The training shall be as user-friendly as possible. And so this is how it looks like. This is the web interface of our software, which is responsible for training. You have to press button start, and the data will be automatically pulled. So the training data. And at the beginning of the training, it makes sense to verify that the training the labeling was done correctly. So here I see 2 categories, clamps and screws. And actually these are pieces which were cut out from the source images And I can verify that everything is right and I didn't make mistakes and I don't have clamps in my screw section. Then I have to wait training to be completed. It will take probably 5 minutes to half an hour, depending from how many categories we have, from the size of the images and so on. And when the training is completed, I can do the test right away. So I have just to activate the evaluation mode, the test mode, and now I can put objects in front of the camera. You will see it started working. So the category 1 objects are clamps and they are marked with the red color, and category 2 objects are screws, which are marked with the green color. So now I'm happy my localization algorithm is working well. So the next step after the training would be to export the data to the camera and make sure it's running there. Export the data of the camera is done in our software. You just get a package with neural network itself, with the settings for the camera. And after the transfer to the camera, we can start the EDS NXT cockpit. This is actually the software which is provided by EDS, and with that software you can monitor the state of your camera, check the images, check which applications are running on the camera. And in my case, there's only one application which runs on the camera. This is our application, which is called iBot. I already selected the clamps model, and you see it is running. So I put objects, and they are detected with the same quality as on the computer. And this is very important. So the computer is not needed anymore. Everything, all calculations are done directly on this camera. What is also important, it is possible to have multiple models on the camera. As an example here, we created a test model which detects tools, screwdrivers and pliers. And I just put a couple of screwdrivers and I will change the model and they will be detected. And this is important because the counterpart of our camera, the robot or the other system, can request detection using different models. So for example, for some use cases, one model shall be used. For the other use case, the other model shall be used. And the camera software will automatically switch to the model which is required and will perform the detection. So now we are sure that everything is working on the camera. Now we can start programming the robot. Yeah, correct. This is how programming the robot looks like. So my goal now is to show that to complete the task, so to program the pick and place operation, no special knowledge is required. So no knowledge of 3D math or programming or any other things. Just robot developer shall know his area, his development environment, and use it to achieve the goal. Here you can see the teach pendant from Universal Robots robot. And on the left side, there is a program which is basically empty. It has only one move. This is go to home position at the beginning, and we initialize the gripper. And what I'm going to do is to add to this program our own node, program node, which is called, again, iBot. And as soon as I created this node, it offers me to select the model. As we already see, the camera provides, or camera contains 3 models, and I'm going to select this one, the clamps, which contains the model for clamps and screws. Another one. Right. So when the model is selected, I want to add a handler. So a piece of code which will be executed when a screw is detected. And I'm doing this by just pressing the button. And the next thing, the first thing which has to do with vision, I have to make a first snapshot. So I put an object in the desired position. I make a snapshot. Yeah, I missed the button here. I make a snapshot. And now I have to add a movement. So I want to move to that object with the robot. So I select the correct node, add the move. Here is on the top right side, you can see the picture of the robot. And now I want the robot to move to that object. To program this motion, I will just use the free drive mode, so I don't have to input any numbers. I just move the robot with my own hands towards the screw. And when this is done and I'm satisfied with the position relative to this object, I'm saying okay, and the program is basically ready. Now, the program, every time when the program will find a screw, the robot will move to the same position relative to the screw. So this is the first test, then I move it somewhere else. And now it's the second test, and so on. What is more important, we try to make it as convenient for developers as possible, for robot developers. For example, the normal use case would be not just to do one thing with one object, but to repeat the same operations for all objects which are present on the picture. And to do that, I can just simply switch the processing mode from best result to all results and run the same program. So it will create automatically the loop, and the robot will go over all items which are present on the image. And that basically it. So to do my programming, to program my robot, to program my pick and place, I just have to repeat the same operations. I mean, pick and place is a bit more complex than just drive over to robot, but the complexity here is not in programming. Complexity here is in the fact that I have to program few movements, but they all done in the same way. So I take one object, put it in the desired position, and then I program using teaching few prepositions. For example, one preposition is a real preposition. The other position is the position for gripping. The third position is position when we go out, and so on. As an example, I can show a final program which we developed for that test. I just dropped these three screws and three clamps, and very simple program will do the job. Of course, this software, this pick and place activities can be combined. So, for example, with pelletize activities, we can collect randomly laying objects and put them into predefined sequence using the other blocks from the universal robots blocks which are available for programming. So to sum this up, to sum our development up, I want to say that first, our goal is to make it as easy as possible to set up and to implement the solution. Second, it is a low-cost solution because it does not require a PC. It requires only one camera. It does not require a special environment, like, for example, the feeder with a light underneath, because we use artificial intelligence, which is able to recognize the objects above on any surface. So basically, if we as humans can see this object, can recognize them, then artificial intelligence can also do this, and it runs on a camera. Our solution is extensible because you can combine cameras and robots. So, for example, one camera can work for a few robots, or one robot can work with multiple cameras. And last but not least, it's the EDS-NXT camera. This means it can not only run the pick and place software from us, it can also run another vision components, like, for example, quality control. So the operation might look like the robot picks an object, then it starts the quality control with the same camera by just showing an object to the camera. And then depending from the quality control result, it can put it in OK or an OK bin. So we're actually looking forward to use our solutions for our customers, and we are very interested. We're already in communication with few customers, and if you have interest, just contact us, either send us your pictures or objects, and we can make a test in our facilities. So I think that's basically it. And I'm ready for questions.
Awesome. Thank you very much. You just mentioned the different components, and there's one question. The universal robot was used in the presentation. Does the camera support other robot platforms?
So our goal was to create the camera software as independent as possible from the hardware. So there's a protocol which is open and which can be used by other robots. We picked up universal robots because it is very user-friendly, and adding a user-friendly camera component just makes a lot of sense. And if needed, we can implement, for example, this interface for customer-specific robot, or even a customer-specific station, probably, which portal robot, things like that. Non-standard robots we can also support. And we are going to extend our plugins collection to add more robots, like, for example, KUKA.